Hello, intro to proofs. This is section 3.3. And I'm going to do the preview activity 1 right here. So this is the section where we learn about tautologies and contradictions. So tautology is something that's always true. Contradiction is something that's always false. And so an example of a tautology might be that there's a kind of a joke that come join the tautology club. Once we have 1,000 members, then we will have 1,000 members. So that's something that's always true. And so the tautology is something that's in something that's always true, and so often it's like kind of a worthless thing to say. Whereas a contradiction is something that's always false. And so you might say, well, that contradicts what you already said. So you said this, and then now you're saying not this. And that's a contradiction. Contradiction is something that's always false. So number 1, we're asked to do the truth table for P and not P. And then P and not P. Well, there's only 2 possible values for P. It's either true or false, which makes this false and true. So combining them with and gives you false and false. I guess I did the contradiction first. And then P, not P, and then P or not P. So the possible values are true and false, which makes this false and true. And they both have a true value, so then or makes them both true. That makes that a tautology. So then we're going to kind of explain the logical reasoning behind proof by contradiction. So we're going to look at this statement. So that was part 1. Not part 1, but number 1 of preview activity 1. Number 2 is we look at this statement. Not Q implies R and not R implies Q. And so we want to show that this is a tautology, meaning it's always true. Let's look at Q, R. So Q can be true. So let's keep that one the same. True, false, false. R can be true, false. Let's make sure that one looks like a true. True, false. All right, now let's break this into stages. So the most inner parentheses is R and not R. So I'm just going to do that as we've already done that. So that's R not R is always false. Okay, so let's do not Q here. And so not Q being false, false, true, true. And then we need to do not Q implies R and not R. And by the way, I forgot, this right here is Genevieve, in case you haven't met her. Hi, Genevieve. I finally got her to sleep. All right, not Q implies R. So then false implies false, so that's vacuously true. False implies false is vacuously true. True implies false is false. It's false. Okay, so the final step is that we now have that thing implies Q. Not Q implies R, and not R implies Q. Okay, so when this thing is true and Q is true, it's true. When this is true and Q is true, it's true. When this is false, then it's vacuously true. When this is false, it's vacuously true. Look at that, we got all trues. So it's a tautology. All right, so number 3, explain why this tautology shows that if the assumption Q is false leads to a contradiction, then you've proven that Q is true. So if you assume the opposite of Q and you're able to prove that you have something that's always false, then you can use that statement means that Q is true. I just did it. I explained it. There you go. All right. That concludes preview activity 1. And so I'll stop here.